We've recently been talking about how compound interest works, and over in Math 340, we recently saw how to solve exponential equations using the natural log function. What we'll do in this lecture is put those two things together and talk about using the natural log function with a equals p e to the rt, which is the formula for continuously compounded interest. Before we actually work with the a equals p e to the rt equation, let's first just recall how to use the natural log to solve an exponential equation. So example 1 says solve minus 2 e to the 3x plus 1 plus 4 equals 0. Remember, this is called an exponential equation. Because the thing we're solving for, in other words, the variable, is in the exponent. So an exponential equation has the variable. And I'm going to emphasize that what I really mean by variable here is the thing we're solving for. In the exponent. And the reason I want to emphasize that the thing I'm calling the variable is actually the thing we're solving for is that when we start working with our compound interest formula, a equals p e to the rt, there's one, two, three, 4 letters in there, any one of which might be the thing you're interested in solving for. So any one of those might be the variable. And part of our task, and I'll talk about this as we go on, part of our task is always going to be to determine which of those letters we're solving for. But here in example 1, it's clear there's only one letter, it's the x, that's the thing we're solving for. So just to review the steps, the first thing we need to do is isolate the exponential expression. The exponential expression is the exponent together with its base. So in this particular example, that means we need to isolate the e to the 3x plus 1. So the first thing we're going to do is take our equation, and I need to subtract 4 on both sides to get rid of the 4 that's on the left-hand side. Now at this point then, I'm going to use the double arrow that stands in for the word implies. So this equation implies that what we have is minus 2 e to the 3x plus 1 equals negative 4. And the last thing we need to do to get that e to the 3x plus 1 isolated is to divide both sides by negative 2 to get rid of the negative 2 on the left. And at that point we have e to the 3x plus 1 equals, let's see, negative 4 divided by negative 2 is positive 2. Now we're ready for step 2, which is to take the natural log of both sides of the equation. So doing that, I have ln of e to the 3x plus 1 equals ln of 2. Remember, we have to do the same thing to both sides of the equation. And what this does for us is on the left, the ln and the e cancel each other out, leaving us just 3x plus 1 equals the ln of 2. Now we finish solving for the variable. So I'm going to subtract 1 on both sides. And that will give me, that implies that 3x equals ln of 2 minus 1. Now, I would really prefer to write this as minus 1 plus the ln of 2. Because when you write ln of 2 minus 1, it's it's not totally clear what that means. It's easy to think that maybe you're doing 2 minus 1 and then taking the ln. Now, that's not actually what it means. If you have a plus or a minus in there, that means that the thing that's being added or subtracted is not part of the input to the log. However, it's visually ambiguous. By the way, to indicate that you wanted to do 2 minus 1 and then take the log of that, you'd have to put the 2 minus 1 in parentheses. So in case you're following along on a calculator, let's just figure out what both of those would be. ln of 2 is about 0.69, and then if I subtract 1, I'm going to get about negative 3.1. Sorry, negative 0.31. Whereas ln of 2 minus 1 with the 2 minus 1 in parentheses would be ln of 1, which would be 0. Okay, that's just an aside about how we write things. Oh, and the point of that was why instead of writing ln of 2 minus 1, I'm writing minus 1 plus ln of 2. Anyway, the last thing we need to do to isolate the x is divide both sides by 3. And that will give us x equals negative 1 plus ln of 2 divided by 3. Now is the point at which you want to use your calculator to compute the answer. Don't use a calculator up at this step yet. And the reason for that is as soon as you pull out a calculator, you're going to get a super long answer with tons of decimals. You're inevitably going to round that off, and that can make your final answer less accurate. The best thing to do is, if possible, wait until the very end to use a calculator. So figure out exactly what you're going to enter into your calculator for x and do it then at the end. So I'm going to take the natural log of 2. I'm going to then subtract 1 from it, or you can think of that as adding a negative 1. They're the same thing. And then I'm going to get the answer for that, subtraction or addition, whatever you called it, and I'm going to take that answer and divide by 3, which is going to give me negative 0.1.